Hello all, welcome back. Today we will be continuing our previous session of your module 1 of CAE-CAM. Myself Sai Krishna. Today I'm from Department of Aeronautical Engineering. I'll be continuing with our topic, which is of mathematics of projection. What do you mean by projection, first of all? Right? To understand it more clearly, it's a simple representation of an object through its shadow, right? And the way in which the shadow lines are made will refer to different types of projection, right? For example, if you are considering an object, or particularly a cube, right? Let me just redraw it. Right? And this is a perspective of a light source, right? Through which a shadow has been cast of the cube or any of the previous or any behind planes or surface, right? Now, in which way these lines or this imaginary lines which will be passing through in a line or in actual axis with respect to your face will be called as a projector, right? Now these projectors are types, many kinds. Basically, if the projector lines are parallel to each other, right? Parallel to each other, then it will be called as an orthographic projection, right? It means these are perpendicular, right? Parallel to each other and perpendicular to your orthogonal plane or the plane which is perpendicular to your lines of projection, right? For example, let me just redraw a small Cartesian system, right? It's a y and x. During this, if there is any surface that needs to be projected onto your xy plane, then the lines which are coming straight forward from the object, which are perpendicular to your base plane or your orthogonal plane. In this case, x and y, right? Xy will be your plane on which the projection has been appeared. So similarly, if an inclination, while projecting an inclination of 30 degrees to be precise, or else whenever a projection plane is inclined, always aligned so that it intersects each coordinates in an axis with object is defined at the same distance from the origin, right? This particular type of projection is called isometric projection. There are many more types of projection, other one called as perspective projection, right? So in the similar manner, projection is basically mean getting a shadow out. Why the projections are necessary, right? Whenever in an engineering product, particularly CAD or CAM, in order to get your drawings better, right? Whatever you are doing as a part of drafting, right? As a part of drafting will be your basic thing, basic sheet in a 2D form of your 3D part given to your manufacturer. So projection gives you all the outline through which a product has to be seen from that particular point of view. So the manufacturer will rely on that particular drafted product or drafted sheet to understand and make further necessary arrangements for manufacturing the part. Now continuing with the same, this is a small example that we will be discussing for your orthographic projection. Let's consider this as my object. I'll be shading it up so you can see, right? This is my edges, right? this is my object through which I want to have projection, or else let me say this is my object through which I want to give it to a manufacturer for producing the same object. Let's say for 100 components, 200 components, whatever it is. Now in this case, I can't give a 3D object to my manufacturer because he will not be able to understand clearly, as well as he will not be actually measure the dimension manually. So in order to do that, this 3D part we are converting into 2D projection, right? Projection. Now, this 2D projection, if you are confining it inside a solid cube, which is very similar to your Cartesian system, which is X, Y, and Z, then whatever the from your viewer's perspective, or the direction where the viewer is seeing, from that point of view, you will be getting the views. The views basically through which you are seeing the object. So based on your views, you will be getting front view, top view, bottom view, left side view, right side view, as well as rear view. These all are your 6 sides of your cube, right? These are your 6 basic views under orthogonal projection. Depending on the type of projection, particularly first angle or third angle, which basically means putting your object in the first quadrant or third quadrant, gives you a series of views that are necessary in order to get your views out or to completely understand an image. In our case, if you're going for first angle projection, right, first you'll be getting a front view, next is any side view that the user requires, either left side view or right side view, then the top view at the base, right? In this case, it's showing it as bottom view, right? In vice versa, whenever you're going for third angle of projection, then first will be top view, then at the down it will be front view. In accordance to your front view, left side view as well as right side view will be projected. Similarly, if and only if required, the rear view will also be added to understand or to display some certain features that are necessary for a manufacturer to understand. Right? Now, next part is nothing but clipping. What do you mean by clipping? It's an important element in displaying the graphical images. Right? Basically, what we usually do for displaying first thing what we understand is basically is to cut. Right? Clipping is basically means to cut at certain sections. Now, while we are doing this is related to your CAD cam and displaying of a graphical representation. Let's, for example, we'll take an example. Let's consider line 1, right? Line 2, line 3, line 4, line 5. 5 lines which are in your 3D or else in a 3D space or 3D workspace or draft section, and you want to see a particular section, particular part of your whole object or a particular edge of your whole object, which you'll be zooming on to, right? You'll be zooming on to a particular section of your whole screen, which you are calling it also clipping rectangle, right? What does a clipping rectangle do? It confines a body or confines a region through which you want to be seen, right? What you want to see for that particular area or region, it will be showing you. Now, under this, let's say you're having these particular 5 types of lines or 5 types of edges that are on your screen, onto where you want to zoom onto your line number 1, right? So what happens during this while displaying, right? They clipping uses certain types of algorithms to either to select or to disseminate a value or a data that is stored to be shown onto your screen. For example, whatever is inside the clipping rectangle, it basically shows because it's a job to do, right? Whereas for any other, it takes up few intermediate points, right? There is a data for all the points that are outside the rectangle. These are not being deleted, but these are being not shown while as and when required by the user. So in order to do that, what it basically does is it will assume or it will consider an intermediate point through which this clipping rectangle is bounded, right? As where the clipping rectangle is bounded, based on the intermediate points, the within the clipping region, all the lines are being shown, or else all the edges are being shown. First algorithm, in order to basically do or basically perform the same necessary operation that we are talking about, is basically Cohen-Sutherland clipping algorithm, which is for 2D elements. Basically line, right? In this, all the lines, whatever the lines we have discussed earlier, are classified whether they are in or out, right? Either in or out. What happens if they are in? We'll be giving some value. What happens if they are out? We'll be giving some value. Few lines, what we have discussed earlier, is very similar, that they are partially in, they are partially out. In those cases, we will not be assigning any value. Now, how this basically works is basically having a 4-digit code where TBRL, right? A 4-digit code denoted by TBRL, where the value of TBRL individually can go up from 0 to 1 or 1 to 0, vice versa, right? Now, what happens in this? As we know, clipping basically takes place with help of a rectangle, right? We'll use this. This is my top surface, this is my bottom surface, this is my right, this is my left. We'll take a better example for your previous slide, right? We'll apply the Sutherland algorithm for line clipping. Now, under this clipping rectangle, what is my top surface? Top, bottom, right, left, right? During this, whenever this particular algorithm is being applied, what happens? From the top, it checks whether if there is any point above the top of the window. If there are any, you will be assigning a value of 1. If not, it will be 0. In our case, in the top surface, are there any points? There are points, right? There are points which are above top of the window, but they are not inside. So both the points are away, so the line is away. In those cases, your t equals 0. Right? Similarly, what about B? If any point is below, you can see point B. Sorry, under line 4, one point is below, and it's intersecting the bottom edge of the rectangle. In this case, it will be 1. B will be 1. Next, what about R? One point is out, right? Second, both the points are out, so R will be again 1. Similar to L, again this will be 1. Now, what will be my case? Case will be basic case. It will be TBRL, which is 0, 1, 1, 1. All 3 ones, right? Now, this will be a small matrix that you can understand for any line that is to be performed. Now, basis on this, right? Basis on this, so top surface is clear, so top will be clear. Bottom, there is an intersection point that is to be stored temporarily. Similarly, in the right as well as left, because there are edges or there are points that are outside of your clipping rectangle. Now, similar to same example, this will be your small matrix which has been made in a similar way of TBRL, right? Now, if you're considering point to point from P1 to P2, what happens? On the top, bottom, right, left. So this is vice versa. This is left, right. Now, as you can see, both left and right are clear, right? Whereas not the top and bottom. If the line is within the bounding box, then all the values will be this, right? If there is any line which is passing from top as well as left side of your box, you'll be having this code. If any line passing through bottom as well as right, you'll be having this code. Similarly, a matrix has been made in order to betterly specify in what way these are being made. Now, what is the disadvantage or disadvantage is whenever you are using clipping, right? Clipping basically means you are zooming on to a particular section, right? Now, during this, the line data, right, or else P7 dash to P8 dash, the line data is being stored in your data, right, in your data sets. Now, whenever it's being zoomed, an intermediate point will be assumed based on your clipping rectangle, right? Based on the clipping rectangle, the data is assumed and taken at the point of intersection of your with respect to your clipping rectangle. Whenever this happens, the data point, let's say for A dash, intermediate point, is being temporarily stored, right? Is being temporarily stored on your memory, and as soon as you're fitting your image or fitting your geometry or graphic out of your clipping rectangle, then this point will act as an intermediary to join with your original point or original line, right? Now, there is a small drawback in this, right? Basically, if we considering this particular section, we'll discuss this particular section. There are two particular shapes or two particular geometries or objects that you are using with your clipping rectangle, right? Now, compare your original geometries are different, right? Basically, your both the original geometries are different, but due with the use of clipping rectangle, what happens? Whatever view you are getting is basically bit more common, right? Bit more common for both the different geometries that you are getting, because whatever your previous algorithm was defined is only for line clipping, right? Line clipping. It will only trim out or show you a particular section of your line. It will not define you with respect to the geometry that you require. So, in order to recover from that, what happened? Hardman has basically developed or reiterated Sutherland's algorithm to create a polygon clipping algorithm. Polygons are basically are represented by n vertices, n-sided polygon with n-sided vertices, where two tests are conducted. If the line or edge of a polygon intersects with the window, which is very similar to your previous one, then the precursor point is added to the output list, right? And the next vertex is outside the window, discard it or else add to the output list. We'll discuss this better, right? And it's your one geometry. This is your geometry one. This is your geometry two. Right. Now in this, of course, this is your clipping rectangle, right? Under this clipping rectangle, what happens? Basically, previous to your line clipping, what happens? If there is any line intermediate, a point is being added to your output file. Previously, it's been not been added, right? First, a line or edge of polygon intersects window edge, which is nothing but a clipping window edge. Precursor point is added to your output list, right? These points A, B, C, D are added, right? And again, this is also clipping. E, F, A, B, C, D, E, F, right? These are my precursor points that are intersected by the geometry with respect to the clipping rectangle. Now in this, if the next vertex is outside the window, particularly in this figure, this was supposed to be an vertex which is outside the window. So that data will be discarded and these two precursor points are joined, forming a complete block, right? Now, or else if there it's not, then it will be added to your output list, right? So as it will be added, it creates small shaded region which shows you the different polygons or different ways to clip out a polygon and differentiate between a polygon and simple edge geometry. Now, hidden line and surface removal. What do you mean by hidden line or surface removal? Basically, whenever an object, particularly this coupling or washer coupling, what we have shown here, is basically an object that is under 3D CAD, basically 3D geometry, right? In order to visualize all the features, right? In order to visualize all the features which are showing up front as well as behind the object, you are able to, or you should be able to hide certain faces or facets, right? All the faces. These are supposed to be hidden. So, in order to visualize that particular body or feature better. So, what happens during this? Whenever it is being displayed, like such a way that particular things are to be done from particular section. Then, if you are hiding it as a whole object, then it will be under only edge model type. Edge model, which is nothing but also a wireframe model, right? Wireframe model. Basically, why hidden line or hidden surfaces are necessary? Because in order to visualize and understand the figure with a particular feature better, you are putting it there. Now, they are, in order to hide a particular surface, if you are selecting manually, then selection of that particular surface will vary, right? Or else the computer needs to have a large processing power in order to clearly solve or clearly show you a back body or else front body. Now in this, there are few algorithms which help us to do that while displaying. First one is your back face removal, second is your depth buffer, third one is a depth sort algorithm. Now in these algorithms we will be discussing further in the next class. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.